Hi students, now we are going to start with the thermodynamics previous year questions. All questions collected with different models. You may not find all questions and regularly it is arranged chronologically with respect to okay with respect to your with respect to the models. Okay, not year wise it is segregated, not exam wise it is segregated. Some questions are from the NEET, some questions are from main, some questions are from the advanced, so that you will be perfect in this chapter once you go through. And while going through this PYQs, you have to mark your difficult topics, then only it will be useful. This session is only to identify your weak areas. Okay, so what you will do while going through this video, you will identify weak areas. Suppose 2 to 3 questions if you are not able to understand or not able to solve, then mark out that weak areas. And after this, I think before this only all of you have gone through the one shot lecture. Okay, so actually this is a frankly speaking, thermodynamics is a 3 chapters. Okay, zeroth law and first law, it is thermodynamics part 1. That's why it is made one shot part 1. Okay, then thermochemistry, then it will be part 2. And thermodynamics third law. Okay, third law it will be part 3. Is it understood? So like this, these are the 3 parts combinedly available, and you can go through them, and after this you will come to know the weak areas. If possible, this Monday I will upload the DPP of this. Okay, or this in few sessions. After few sessions, I will try to upload the DPP on this topic. Okay, so then you will come to know what will be the future questions like. Understood? So the same thing you can do it for all chapters. First of all, one shot, second PYQs, then DPP, then only that lectures where you are having the okay. So they will be having the okay. Only they will be having what? Only they will be having the difficult topic. That topic you will go through it. Okay. So let's start this session one by one. Let me clear this, and here comes the first question. Okay. So this is the most mistaken question, and while explaining I will also tell what the previous students have done mistake. Okay. So the question is, the direct conversion of A to B is difficult, hence it is carried out by the path followed. Understood? So now you have to find out. EU is something given. Okay, you don't worry about that EU. Okay, European units or something like that. You don't worry about that unit. Now you have to find out total entropy change from A to B. Total entropy change from A to B you have to find out. Okay, it is just like application of the Hess law, but you will be applying it for the entropy. Normally Hess law is applied for enthalpy, but here it will be applied for the entropy. Let's see, will you be in the trap given by the question or you are out of the trap? Okay, here answer to this question is B. What is the answer? B option. Okay, but how it is and where the students have done mistake, that I am going to tell you. Okay, so here why it is B. See, from what we wanted to go directly from A to B. Okay, from A to B it will be A to C, C to D, and A to B. See, from A to C it is 50. Okay, but it is given as 50 plus and 30, C to D 30. But see here how they are giving, they are fooling you. B to D is given, but we want to find out D to B. Okay, so if B to D is 20, then D to B will be minus 20. 50 plus 30 minus 20, that is 80 minus 20, 60. That's why it is plus 60. Okay, so where was the trap? Is it understood? The trap was hiding here. Understood? So let's see the next question, and I will try to give the PDF of this. You can go through it afterwards also. In the comment section you can go through it. Okay, this is JEE 2007 paper 1. Once there is a paper 1, paper 2 like that, that can be advanced question. Okay, then the value of log 10K for this reaction is delta G is given, delta S is given, and log K we have to find out for the reaction. Okay, let's see who will solve it and who will solve it correctly. Okay, very simple question. This one here already it is given delta G value, delta S value at a reaction. Once the reaction is at equilibrium, okay, this value multiplied also given, so that you need not to worry about it. Okay, delta G is equal to two things are there: delta H minus T delta S, and delta G is equal to minus nRT. Okay, minus nRT log K. So by using these two relation and substituting, we will get log K is equal to, directly we want the log K value only, need not to take the anti-log. Okay, so you will get B answer. What you will get? You will get the B answer. Okay, now let's see the next question. The process of H2O 1 liquid at 1 bar. The process of H2O liquid at 1 bar. Okay, liquid at 1 bar and 373 Kelvin. This temperature is very much important. 373 Kelvin is boiling point of water. Okay, H2O gas at 1 bar. That means it is at equilibrium. Then the correct set of parameters. Correct set of the parameters you have to identify. Okay, very simple question. See here, for this, because of this temperature, I am telling you what to understand: 373 Kelvin and 373 Kelvin. Once both are 373 Kelvin, equilibrium. So at equilibrium, delta G will be equal to 0. Okay, what will be 0? Delta G will be 0. Here also 0, here also 0, but it cannot be. It cannot be. Now here, it is from the liquid to gas. It is from liquid to gas, so entropy will be increasing. Therefore, delta S is positive. So A option is correct. Which option is correct? A option is correct. Okay. I think it is clear now. Let's move on to the next question. Okay, next question is again from the advanced exam, and it is paper 2 question. So that's why it is given functions is oblique or, that means more than one correct. You have to identify the state function: internal energy, irreversible expansion work, reversible expansion work, and molar enthalpy. Out of this, how many of them are state functions? How many of them are state functions? Okay, here internal energy. Internal energy is the state function. Internal energy is the state function, and molar enthalpy also state function. Okay, so A comma D are the correct answers. As it is a entrance examination of advanced, therefore it is having more than one correct options. Okay, so then let us move to the next question. Now, next question is according to the following, the intensive property. Intensive properties are intensive property, extensive property, the substance, the properties which does not depend on, any type of, that does not depend on a quantity, but depends only on the nature of the substance. They are called as intensive. If they depend on the quantity, then it is called as a extensive property. Okay. Okay, here intensive property, that means it should not depend on the quantity. Here in the molar word is used, so you can take any amount, but we will calculate per mole only. That's why it is intensive property. EMF also does not depend on the quantity. Okay, resistance, more length, more width, there, like that variation will be there. Here if it is molar heat capacity, then it will be also answer. So answer is A comma B. What is the answer? A comma B are answer. Next, by the species which by definition has zero standard. Okay. So here bromine is there, but it is in gaseous state is there. Therefore, it is not correct. If in the question, if it is in the liquid form, then it will be correct. Okay. So chlorine in the gaseous state is exactly correct. H2O is not correct because it is in compound state. Elementary state and standard state also must be there. It is also in compound state, so only B answer is correct. Okay. For this question, B answer. For this question, A and B. A and B are correct here. Okay. Here only B option is correct. Let's move on to the next question. I think every explanation is clear now. Okay, next question. Next question here it is, using the data provided, calculate the multiple bond energy C triple bond C in the C2H2. The energy is the taken bond energy of CH is 350 and for this reaction it is given. Okay. So by using Hess law you have to solve. I hope all of you can do and tell me. Okay, here this is the main reaction. In this reaction, what you have to find out, bond enthalpy, enthalpy of reaction. Okay, enthalpy of reaction is how much? 225. This you will substitute here. During this reaction, carbon is sublimate. Carbon is undergoing sublimation. So at this place you will write 1410. And for one carbon it is 1410. Therefore 2 into enthalpy of sublimation of carbon, okay, plus bond energy of hydrogen. In hydrogen, bond energy given over here. So, and how many hydrogens are required? Only one hydrogen. Therefore, you can directly keep it here. Then bond energy of carbon and hydrogen. See, in C2H2, this will be the structure. This will be the structure. Okay, C2H2. This will be the structure. Now, this is the bond energy. This is the another bond energy. Okay. So, single bond and single bond. Two single bonds of and one bond energy of double bond. One bond energy of double bond. So, all are known. This bond energy is also not known. If I consider this as X and simplify, I will get 815. What will be the answer? Answer will be 815. Okay. Note down this. Then we will go to the next question. Next question is standard. Next question is standard enthalpy of formation of CO2, H2O and glucose. CO2, H2O and glucose are minus 400, minus 300, minus 1300 kilojoule per mole respectively. Then enthalpy of combustion. Here the very important term you should remember is enthalpy of combustion per gram of glucose. So you will get the answer, but you should divide it by the molecular mass, because whatever the answer you will be getting, that will be per mole. That will be what? Per mole of the gas. Okay. So this is the per mole of the gas. Okay. Now let's see. I will explain. Okay, see on this board I am explaining. During this enthalpy of combustion of glucose, what is the glucose formula? C6H12O6. Okay, plus when it is undergoing combustion in terms of the 6 moles of oxygen gives 6 CO2. What it will give? 6 CO2 plus 6 H2O it is going to give. Okay, now enthalpy of combustion of glucose is equal to, here how many products are there? Enthalpy of formation. Enthalpy of formation of carbon dioxide into 6. Okay, plus 6 into enthalpy of formation of water. Okay, this is the enthalpy of formation. Okay, into 6 of water into 6 of carbon dioxide minus enthalpy of formation of 1 mole of glucose. Then you will get answer of, so here this is the equation, C6H12O6 plus 6O2 gives 6CO2 plus 6H2O. So enthalpy of reaction, actually in this enthalpy of combustion only, enthalpy of combustion of glucose is equal to product minus reactant. In the product 6 moles of CO2 and 6 moles of water. In reactant oxygen is not considered. because it is already in elementary state. Minus of minus 1300, it is enthalpy of formation of glucose. So finally we got enthalpy of combustion, but answer must be per gram. So this is for 180 gram. What is 180? 180 is the molecular mass of the glucose. 180 grams gives 2900. Then 1 gram per gram we require. So 2900 kilojoules. This is also okay. And answer is also in kilojoules. So you don't worry. When you divide it with 180, then you will get 16.11. As it is a exothermic, this will be minus 16.11 kilojoule per mole. Okay. So this is the answer for this question. I think it is clear now. Okay. Now let's go back to our question. Okay, this question is understood. So minus 16.11 is our answer. Now let's see the next question. Then heat of combustion of carbon and carbon monoxide. This is very famous question and I have covered in my lectures also, because this is the importance of this question. Okay. And heat of formation of carbon monoxide is okay. So this is already explained in my video lecture. Just I will give you a hint. Carbon to carbon monoxide to carbon dioxide. Okay. So heat of formation, this you want, understood? Then heat of combustion of carbon, this is given as minus 393. Heat of combustion of carbon monoxide is minus 283. Then heat of formation of carbon monoxide per mole you want, okay? Heat of combustion of carbon monoxide per mole, okay? Just try, otherwise I will tell you. So this is also I am explaining on the board. First of all, enthalpy of combustion of carbon. C plus O2 gives CO2. Okay. Let us take this as equation 1. This is equal to minus 393.5 kilojoule. And second one is given enthalpy of combustion of carbon monoxide. So CO plus half O2 will give CO2, and it is equal to minus 283.5 kilojoules. Okay. Now we want enthalpy of formation of carbon monoxide. So C plus half O2 gives CO. This reaction we want. Simply it is minus 393.5 minus of minus plus 283.5. Answer will be minus 110 kilojoules. Is that clear? What is given and what is asked? This equation we have to find out. Rest all are given. Okay. Okay. Next question is 1 mole of ideal gas at 300 Kelvin in thermal contact with surroundings expands isothermally from 1 liter to 2 liter. See here, main word is against a constant pressure. That is what you have to consider at 3 atm, 1 liter and 2 liter. Okay. And 300 Kelvin. Is it understood? In this process, change in entropy of the surroundings is, and also we have to find out the entropy change of the surroundings is. Okay. So the formula I will tell you, you can substitute and do it. Delta S surrounding. Delta S surrounding formula will be minus P external. Minus P external V final minus V initial. Okay. Divided by T. Again I am reading out minus P external V final minus V initial by T. Okay. So P external will be 3 atm. Here it will be 3 atm. Final volume is 2 liter and initial volume is 1 liter. So temperature is 300 Kelvin. Just by substituting and you will get C answer minus 1.013. Minus 1.013. Okay. So these are our questions about the second part. Okay. Now let's see the next question. You remember the formulas, that derivation also I have told you. Okay. Next, delta U equal to. Delta U equal to. Okay, it is just a theory question and answer to this question is adiabatic work. Answer is adiabatic work, because adiabatic means heat is not coming. So whatever the work done at constant heat will be through the internal energy only. Okay. Now this type of question just now we have solved. See, these three equations are given. Okay. These three equations are given and question is three equation values are given. Based on the above thermal equation, find out this reaction. Okay. So similar type just now we have solved, but values are different and approach is minor difference is there. Okay. So in this question you will get minus 748. I think you will be able to do this. Okay. So answer is D option. Okay. Now let's see the next question. The combustion of benzene. The combustion of benzene gives. This was also main problem. Here I will mark out where the students have done mistake. Okay. Here it is given benzene is in liquid form. So don't count the number of moles of benzene. And you need not to remember it is in liquid state or gaseous state. And water is also in liquid state. Okay. Anyhow, obviously at 25 degrees water will be at liquid state only. The formula you will be using delta H is equal to uh, delta U minus T. Delta H is equal to delta U plus delta NGRT. Okay. So heat at constant pressure. Heat at constant pressure only delta H. Okay. And it is given at constant volume. So this value whatever we are given with, that is delta U. Okay. What is that? That is delta U. And temperature will be 298. R value will be 8.314 divided by 1000. Why 1000 can anybody say? Because it is in kilojoules. Because it is in kilojoules. Is this understood? Okay. Now is it clear to all of you? Okay, next, which one of the following equation does not correctly represent first law of thermodynamics for the given process involving ideal gas is given for cyclic process, whether Q is equal to minus W or not. For isothermal, Q is equal to minus W or not. Okay. Correctly represents, you have to identify. Does not correctly represents. Okay. Okay. Here the question is does not correctly represent. Okay. Does not correctly represent. Just now we have studied first law of thermodynamics for the ideal gas. So answer is C. What is the answer? C. Then correct order of hydration of enthalpy of. This is very famous question, S block question, but here it is hydration enthalpy they are asking. That's why we have to give it here. Smaller the size and higher the charge, higher will be enthalpy of hydration. Okay, enthalpy of hydration. So A answer is correct. In this question, what is correct? A answer is correct. Okay. So shall we go for the next question now? Okay. Next, for silver Cp, in joule Kelvin inverse mole inverse is equal to. This is the equation form. You have to convert into Helmholtz equation. Okay. So I am writing Helmholtz equation. Delta G is equal to delta H minus T delta S. Delta G minus T delta S. Okay. So here Cp, and when you convert this into Clausius Clapeyron equation, then it will be easily understood. Okay. Otherwise we can write it as a delta H is equal to, it is equal to NCP delta T. NCP into delta T also. Okay, understood. So here 3 into 3 moles of, here what is given, N value will be how much? 3 moles. So 3 into, and in place of Cp I will write Cp is just nothing but delta H value. Cp is just nothing but delta H value. Okay. So how much it is given, that the total Cp value I am substituting here, 23 plus 0.01 T. Understood? And then T delta S will remain same. Then the value of delta H will be. So just on comparison, you can compare or simplify, that is up to you. Answer you will get 62 kilojoules. Two equations are combined here. Delta G is equal to delta H Ts, and by substituting the in place of the delta H NCP delta T, we will get the actual value of delta H. Okay. Next, 5 moles of an ideal gas at 100 Kelvin allowed to undergo reversible. First of all, see here, ideal gas is given, reversible given, but only thing compression is given. The temperature becomes 200 Kelvin. So initially temperature was 100 Kelvin. Now temperature became 200 Kelvin. Okay. Then Cv is equal to 28 Joule Kelvin inverse. Calculate delta U and delta PV. So here delta is applicable for both pressure and volume. It is applicable for both pressure and volume. Is it clear? So when what is the formula for delta U? NCV delta T. Okay. What is the formula? Delta U will be NCV delta T. So delta T is already given 200 to 100. Okay. And CV what you wanted to find, and CV is given here 28. And number of moles, 5 moles are given. So just by substituting that, you will get A answer. Delta U will be 14 kilojoules and delta PV is simply a delta H value only. What is that? Delta H minus delta U. See, delta H is equal to delta U plus P delta V. So this value we want, so delta H minus delta U. Okay. So that minus 10, 14 minus this work done also you have to count, that will be 18 minus, not 18, 18 minus 14. This is 14 and this is 18. So total value will be 4. Okay. Okay, see, this question is based upon this formula. W is equal to minus nRT ln V2 by V1. Okay. So two different temperature it is given, T1 less than T2. So from this what we will conclude, that temperature is higher, then slope will be more. Okay, temperature from this equation. So this is the formula V2, this will be V final will be here, it will be plus. Okay. So this is the slope deciding factor. So once it is says T2 is greater than T1, that means slope must be higher. So here also slope and here also slope is higher. Here also slope is higher. Here also slope is higher. But after that intercept volume, okay, final volume, work done dependence on the final volume. Okay. So intercept of the curve 2 is more negative. See, when I extend this, the curve 2 should be negative intercept. Okay. This negative will be there only in this. Otherwise, see, it is 0. Okay. It is 0. And it will be, sorry, it will be like this and it will be like this. Okay. So answer will be B option. What will be the option? Why B option is it understood? Slope of the T2 is higher and it will give you the more negative intercept. More negative intercept. Okay. So option B is correct. Okay, next question is entropy change associated with conversion of 1 kg of ice. Okay, always remember whatever you will be given here, specific heat of water, specific will be per gram. Okay, 4.2 kilojoule. See here, they have changed here, kilogram also given. And for liquid water and water vapor, both are given. Heat require liquid fusion, vaporization. Actually here it will be from ice to liquid, liquid will be constant and liquid to gas, and again it will start increasing, then it will be like this. Okay. So from here to here this will be constant, from here to here it will be constant. You have to take total 4 places, increasing constant, increasing constant, increasing constant. If you add all of them, you will get 4.26. How much you will get? 4.26 value. So answer will be D option. For this question, what is the answer? D option will be the correct answer. Okay.